Hi, this is Ms. Jensen, and today we are going to talk about graphing inequalities. So I wrote down the steps to this particular problem already on the left. We're going to start with graphing the equation. So it's an inequality, which means it's less than or greater than. I'm going to graph the equation. Y equals 2x minus 5, which means y-intercept of -5 and a slope of 2. So right 2, up 1, right 2, up 1, right 2, up 1. Keep on swimming, keep on swimming. All right. We're going to ask ourselves, is that line going to be dotted or solid? Well, notice this is less than, there's no line underneath, so it is going to be dotted. I'll go over it in blue. Step 3, we're going to test a point. Usually we test 0, 0 just because it's easy. So this is where 0, 0 is. Very easy to plug in 0 for y and 0 for x. Okay? So if I do that, I'll rewrite the same thing here. 2 times 0 minus 5. I'll ask myself, is it true that 0 is less than -5? Well, that is not true. This was a no, which means everything on the left is not true. Everything on the right of the dotted line is true. So every point on the yes side would make that inequality true. All right, we'll try another one. Now this one is in standard form. If I want to, I can graph my equation by solving for y and then graphing it just like I did the last one. But I'm going to just remind myself here, remind you guys, if you want to leave it in standard form, you can find the x-intercept and the y-intercept. So if I plug in 0 for y, that means this whole y term disappears. I end up with 5x equals 6. 6 divided by 2 is, 6 divided by 5 is 1.2. If I want to plug in 0 for x, 5 times 0 just makes that term disappear. Divide both sides by -2, and we get -3. Okay? So, my one point is 1.20. I have another point at 0, -3. I'm going to go on to step 2, ask myself if it's dotted or solid. Well, this is less than or equal to, so this is going to be a solid line. So try to do the best I can to make a nice straight line, not too shabby. I'm going to test a point. I can test anything I want to, but we usually test 0, 0 because it's easy. It's just if it goes through 0, 0, then I would want to test something different. So this is 0, 0. I'm going to go to my original 5x minus 2y and ask myself if when I plug in zeros, is it true that 0 is less than or equal to 6? That is true. That is a yes. So we are going to shade, well, because this was a yes, the other side has to be a no. I'm going to shade to the left in this case because that's where the yes was. All right, I just wanted to show you 2 special cases, remind you what we do if it's y equals -2. I know it's y is less than -2, but we have to start out with graphing y equals -2. And that is a horizontal line. Step 2, I'm going to ask myself if it's dotted or solid. There's no line underneath, so it is dotted. So I'm just going to keep it at that. It's like, well, that looks like a dotted line to me anyway, so keep it at that. I'm going to test 0, 0. So we'll test this point here. So the only thing I can plug in for is y. And when I replace y with 0, I ask myself, is it true that 0 is less than or equal to -2? And that is not true. So above the line is a no, below the line is a yes. We're going to shade that side. One more special case is x equals 5. 1, 2, 3, 4, 5. So this is x equals 5. When I ask myself if it's dotted or solid, well, it's greater than or equal to. So this time, this one is solid. So another special case with the vertical and horizontal lines. I can test 0, 0 again, but why not this time? I mean, I can test any point. I'm just going to go 1, 1. I could do right 8 up 9. It doesn't matter. But I'm just going to, what the heck, test 1, 1, which means if I plug in x for x, if I plug in a 1, just try to write that a little bit better. Instead of x, if I try to plug in a 1, I'm going to ask myself, is 1 greater than or equal to 5? And that is a no. It's a no, so I'm going to write a no here. And I want to shade towards the yes side. So everything on the one side is no, everything on the other side has to be yes. So I said no, we're going to shade towards yes. That is a D. It doesn't look like a D, but we'll go with it for now. All right, I want to do one last one, and this one is compound inequalities. So for compound inequalities, there are really two lines. So we're going to write, try to make that a little bit better. Write and graph two equations. And those two equations are the left side, which is -2 y plus 2x. And if I solve for y here, or I can keep it in standard form, but usually it's easier to solve for y, I'm going to change this to equal, because really all we care about is the equation. But I'm going to solve for y by minusing 2x from both sides. Okay, so I just positive 2x became negative 2x on the left. And if I switch this around, this is just the same as y equals negative 2x minus 2. Okay? So that's that left equation. Now I'm going to do an equation for the right side. Y plus 2x equals 6. And again, if I want to solve for y there, that's the same as negative 2x plus 6. Okay? So I'm going to graph this one. I'm going to graph this, and it has a y-intercept of -2, slope of -2 as well. Okay? And when I go back up to here, notice this left side is dotted. So I'm going to just keep this as dotted. All right? So that -2, that left equation was dotted, so we made that dotted. I'm going to go do the second one, y equals negative 2x plus 6. So 1, 2, 3, 4, 5, 6. So y-intercept of 6. I'm going to go down to right 1. Okay. And I'm going to look here as well. And I noticed this also does not have a line underneath it. So there's no line underneath that one as well, so this is going to be dotted also. Okay, so now for the shading. We can test 0, 0, and I'm going to go ahead and test 0, 0 in the original inequality. So when I test this one, I'm going to go -2, we'll leave a blank there for y and a blank for x. Okay, and I end up with -2 is less than 0. So I'm going to ask myself, is this true? Is 0 in between -2 and 6? Yes, that is true. So when I tested this, this was true. This was a yes, which means outside the double lines is going to be a no. So this would be a no, this would be a no. So in this case of a compound, you're either going to color in on the inside or the outside. Well, inside the two dotted lines was true, so I'm going to shade that, and I'm going to ignore what's on the outside because that's a no. If we had plugged in 0, 0, which that usually shouldn't happen, but if we plugged in 0, 0 and it were a no, then we would shade the outside. But since it's in between the two numbers, it should be shaded in between. That is all for shading inequalities. Have a good rest of the day.